Okay, let's start. So now you have to enter in the chapter 2. Same basic class we have to study in the chapter 2 also. So we'll study introduction with the basic class, and what we studied in chapter 1 also will cover. Now Ohm's law we have to study here. Next we study nodes, branches and loops in this chapter. Kirchoffs laws we'll study. Series resistor and voltage division. Whenever resistor in series, their voltage will be divided. So that we'll study. Now parallel resistor and current division also we'll study. So star delta or Y delta transformation. Y is also called as star, and delta transformation. Star delta or Y delta transformation is called. No, after the listen to the class, because you should not read it. Now, step by step, we'll study all the chapter in 3 classes, inshallah. Then we have the quiz from chapter 1 and chapter 2. Now, once the chapter 2 is finished, I will upload the slides, inshallah. Now, let's revise our chapter 1. Introduces fundamental concepts like current, voltage, and power within an electrical circuit, with the electrical elements also we can say. So we studied like current. Before the current we studied charge also. Charge, current, voltage and power we studied in the chapter 1, and we had some problems. I solved the problems also. Now in chapter 2 discuss the essential laws of Ohm's and Kirchoffs laws governing electrical circuit to understand these values. Means how to apply these voltage, current and power to the bigger circuits in the bigger perspective in a shorter time. How to solve those. Then we need laws and its methods we have to study. So in chapter 2 we study about the laws, Ohm's law, Kirchoffs law. In chapter 3 we will study about the analysis methods like mesh analysis, node analysis we will study there. In chapter 4 we have bigger problem solutions like theorems, theorem, Norton theorems, maximum power theorem. Now today we will study the chapter 2. So chapter 2 also covers various techniques used in circuit design analysis, including combining resistors, series and parallel, voltage and current division, and delta to Y or Y to delta transformation. Because circuit means the resistor maybe comes on either series or parallel, or comes under star or delta formation. So we all these 4 categories will study: series, parallel, star and delta formation. The focus in this chapter limited to the resistive circuit only. So we are not going to the AC analysis, only DC circuits we are studying. In this we are studying resistive circuits only we will study. Resistance only we covered, not inductance, not capacitance. The application of these laws and techniques extends to practical scenario like electrical lighting and design of DC meters. So let's start our chapter. What is the Ohm's law on a resistor? So there is a equation or proportionality equation we can say. Voltage, whenever you increase, the current will also increase in same fashion with a proportionality constant, that is called a resistance. In general term I am telling. First actual definition you can see. In general, materials resist the flow of electric charge. That will come the equation of voltage, current and resistance later. First understand what is resistance. So in general, material resists the flow of electric charge. So different materials in the universe we have, that is copper, silver, wood, and different materials we have. So each material has some property which will oppose or allow the charge movement or electron movement, we can say. This is called resist of electric charge, means flow of electric charge. What is the flow of electric charge? It's a current, movement of the current. So which will oppose or resist, means it will hold, you can say, or it will behave like I will not allow you to move further, or it will be more strong that electrons will not move. So like that, resist the flow of electric charge. The ability to resist current is known as resistance. This ability means this behavior, this inner property is called resistance. Means resist, name itself is there. Resist means stop or control. Resistance. You are resist for your nafs. If you control your nafs, then good iman. Iman will improve. Will go to the Jannah, right? Will do the good deeds. So like this here also resist means control. So the the ability to resist current is known as resistance and is represented by a symbol capital R, not small r, capital R. Okay. The resistance of any material depends on uniform cross section area. It's called cross section is the section, cross section area. Composition also we can say the area in terms of meter square. Cross section area A and its length means the wheel. The wheel means length. How much is its length? Length as shown in the figure, it will show. Mathematically it will represent as R is equal to rho L by A. What is the resistance? Based upon the material, not Ohm's law here, based upon its construction, its material, copper, silver, wood, anything. Based upon its material, R is given by rho L by A, where rho is the resistivity, L is the length, and A is the area. So the figure shows like this. Now this is the, let us say, one silk material, silk means wire, which has a length of L, the wheel, and cross section area means how much is the cross section area, then multiplied by the diameter. Based upon this structure, we have to find its area first. If it is in the square shape, cross section area, what is the cross section area of a square? Length into length. If it is a rectangle, what is the cross section of rectangle? Length into breadth of the wheel and other. So like this, the wire will be which other circular area and its length will be there. So the equation will be different for area. So area and length. Now material, what is rho? Material resistivity. It may be a copper, it may be a silver, it may be a gold, it may be a wood, or it may be anything, any wire or any material. So its value, resistivity, how much ability to control, how much ability to stop. It's called material resistivity. Now it is denoted like this one, zigzag between two terminals. Okay, this is the shape of the resistance. Be careful, don't put like round. No, zigzag, zebra. This one. This is the resistance, and R is its a symbol capital R, and plus minus is the voltage across this resistance. We will call plus minus V, and current entering from one point to other point. Current enters in one point to other point or one terminal, and it will leave from other terminal. Current direction is this one. This is downwards, and if it is upwards, another way is upwards. So, and its resistance is given by R is equal to rho L by A. Rho is known as resistivity of the material in ohm meter. This is a ohm meter. This is so L by area. L is meter. Area is meter square. So meter will cancel. So resistance will be the ohm meter. R is in ohms. This meter will come here. So ohm meter is your resistivity unit. What is the resistivity unit? Ohm meter. What is the unit of the wheel? Length. What is the unit? Let's say this is my length. What is the unit for this? Hada tawil. Kam hada. Khamsa. What is khamsa? Centimeter. Mumkin khamsa meter. So in this we call it as meter. Okay. Hada meter. Hada tawil. Now what is the area? My body area means I have to length, height, breadth, and circular. Everything will be there. So meter square. Meter square is area other unit. Okay, so like this. So now good conductors such as copper, aluminium have low resistivities, while insulators such as mica, paper have high resistivity. So mica, wood, paper, okay, glass, these are insulated, very high resistivity. We'll see the value, no problem. What is the rho? We will see that value, how much resistance it is. Silver, gold, it has. So now this table, check the table. Silver, what is the value? 1.6 watt, 10 power minus 8. Means minus 8 means sagir, means very small value. Means it can allow anything. Come to the Teflon. What is the Teflon? 3 into 10 power of plus 12. Very high value. Means Ashra power itne kam ada Mia. Ashra power talata kam Alf. 10 power 3. What is 10 power 3? It is 1000. But here how much it is? 10 power itnash means how many zeros? So that much big value it is, so the electrons or charge will not allow. It will stop whatever the voltage you give. No, it will not move any charge. So these are called insulator. Wherever the plus is there on the power, 10 power 12, 12 plus 11 plus 10 plus 2. What is on? 1, 2, 3, 4. 1, 2, 3, 4. First one. Silicon. Silicon 6.4 10 power 2 plus 2 it is. Means only Mia. Means come ada Sita Mia Arbain. Right. Sita Mia Arbain, right? 10 power plus 2. 10 power 2 means Sita Mia Arbain is the value for the silicon. What is this? What it is called as? You will study in the next subject, semiconductors. Anyone studying semiconductors? Semiconductors, maybe in the next term we will study there. It's called silicon, germanium are called semiconductors. Means conductor, semiconductor. Means show a conductor. Means it will allow, mafi allow. It's mafi full insulator, means stop the current. If mafi full conductor, means it allows. So in between hala. So in these two material only we'll have semiconductor, germanium and silicon. So see here, germanium, how much? 10 power minus 2. This is also very small. And silicon, 10 power 2. This is also small. In terms of hundreds, this is 10 power minus 2. So it is semiconductors. Here or here. If you give more voltage, it will act as a conductor. If you give less voltage, it will act as a semiconductor or insulator, like that. So now see here, very small value here, 10 power minus 8, minus 8, minus 8. Very second value means it doesn't have resisting ability. It won't resist much. If you give the small voltage, then electrons will move. So this is called conductor. Silver, copper, aluminium, gold, carbon. These are all conductors. Okay. But the problem is here, I think gold is there. Yeah, gold is also there. 2.45, 10 power minus 8. So which one is the best one? Silver. 1.64. Next, copper. Next, aluminium. Okay. But generally in our turbine, we use copper 1.72. Okay. And for outside, we use 2.8 10 power minus 8 conductor aluminium outside with a steel. We use it. But not silver. Why silver we are not using? It's very, very costly, rare material, right? Costly. Silver is very costly. Okay. So these are the numbers for resistivity. No need to add. Just you must know which is have low and which is have the high. That's it. Okay. Because in exam, if they ask, they will give the what is the value of this one. It is supply. What is the rho for this material? It will give the value because we can't by heart these many things. Okay. Just you know which is the smallest, which is the maximum. In conductors, smallest, 10 power minus 8. First comes silver, copper, aluminium, gold, then carbon. In insulator, first comes Teflon, glass, mica, paper, like this. You have to remember. These are the insulators. Okay, now coming to the Ohm's law. So this already you know that the material length and cross section and rho is the resistivity. It is the symbol and where the voltage across the resistor and current inside the resistor. Then the circuit symbol for resistor is shown, where R stands for resistance of the resistors. Already we studied. The resistor is a simplest passive element. What is the passive and active element? I already told you. Passive element always absorbs the energy. Active element always absorbs and give the energy back. Active elements. Like voltage source, current source, these are the active elements. Amplifiers, these are the active elements. We studied in the chapter 1, which are the active elements. Passive elements like resistance, inductance, capacitance. When they absorb the energy, it is called passive elements. So, simplest passive element, it comes with the resistor also. Now, what is the Ohm's law? The definition for the Ohm's law. Ohm's law states that the voltage, if we give a voltage on the resistor, the voltage across the resistor, is directly proportional to the current, flowing through the resistor. So, whatever the voltage if we give, increase the voltage slowly, the current will also increase slowly. So it is called directly proportional. That's why the symbol is this one. This is called directly proportional symbol. Means how much voltage increase, that much current will increase in proportionality. Means 5 volts equal to 5 amperes. It doesn't mean. Means voltage increase, current also increase. Voltage decrease, current also will decrease. That's called proportionality. Okay. Now, how much it is increasing? We have to know, because we don't need proportionality, we need equal to. Any equation is always with equal to. So that is given by a proportionality constant. Ohm, that's a scientist name. Ohm is the scientist name. Defined the constant of proportionality for the resistor to the resistance is R. No, I want this proportionality, voltage increase, current increase, voltage decrease, current decrease. But I don't want. I want a equation, exact equation. That equation must have a proportionality constant. If voltage 5 volt increase, then current, how much it is increased? It is based upon the material value, material resistance value. So V equal to Ri, IR also we can say, or Ri. The proportionality constant is R. So V is equal to IR. Vi is proportional, we know. How much is R? This is R times, R zerg with current. That much is a proportional. V is equal to IR. Now the resistance R of an element denotes its ability. The resistance R of an element denotes its ability to resist the flow of electric current and measured in ohms. So this R is the ability to resist the flow of current. How much? If you increase the voltage, how much current is increasing? It can control. The resistance will resist the ability of flowing the current. That's called your Ohm's law. So then it is measured in the ohms. R is measured in ohms. So R is equal to, if you rearrange this equation, R equal to V divided by I. V divided by I. So 1 ohm is nothing but volt per ampere. Volt per ampere is the unit. Sometimes I can miscommunicate, or I can rearrange the phrase. Resistance unit is volt per ampere. True or false? True or false? We know resistance unit is ohms. True or false? Ohm. It's true. Universal. Resistance unit is ohm. Ohms is true. But I can rephrase this equation, this question as resistance unit is volts per ampere. True or false? True it is. 1 ohm is equal to 1 volt per ampere. Volt per ampere is also true. Its exact unit is ohm, but volt per ampere is also true one. So the tricky questions may be asked in the this one. To apply Ohm's law, we must pay attention to the current direction and voltage polarity. Now we have to know Ohm's law, how it is applied, whether current is flowing inside or outside, or voltage plus minus, how it is denoted for each resistance, plus minus or minus plus. We have to understand the voltage polarity and current direction. Then only we can understand. So the direction of current I and the polarity of voltage V must conform with the passive sign conversion. Passive sign convention means current enters a resistance with a voltage polarity plus. It means the resistance takes the energy, dissipates energy. Come faster. Coming late and going out, what is it? Okay, this implies that current flows from higher potential to lower potential in order to V is equal to IR. So, plus if current enters, then that is the higher potential. When current leaves, the minus means that is the lower potential. So, V is equal to IR is the passive convention for power dissipation. Now, current flows from lower potential to higher potential is minus IR. Current going out from the plus terminal of the voltage, then it is called minus IR. We'll practice those in the problems in the future, no problem. So, what is the relationship between voltage, current and resistance? So, V, IR already you know, we must know. So, remembering V is equal to IR, RV is equal to RI, how to equate this one? We have a triangle equation or pyramid equation. Pyramid picture we have. From there, we can do easily. See, put the voltage on the top in the pyramid, in the down, I and R. So, V equal to is nothing but IR zerg. Now, I equal to V taqsim R. I equal to V taqsim R. Now, what is R equal to V taqsim I? R equal to V taqsim I. Easy? So, jumbo hada IR means zerg. Four kind tahat means taqsim, right? Yes. So like this you can remember V on the top, I and R on the down. You can rechange R and I, no problem. It's up to you. V must be on the top. Okay, now done. Yeah. Yeah, now here there are two extreme possible values of resistance R. What are the extreme values? You can see an element with R equal to 0 is called short circuit. Now substitute here V is equal to IR. Now resistance value is 0. What it means? The voltage, whatever the current, the voltage will be 0. 0 means there is no voltage here. There is no voltage means current is infinite, maybe current may be some value, but resistance is 0 means there is no ability to stop the current. There is no ability of the material to stop the current. Means what? Means complete whatever the current is coming is going from one point to other point. No one is stopping there. So resistance is 0. So the voltage will be 0. There is no stoppage. So this is called short circuit. When there is R equal to 0, then the voltage will be 0. As for the equation, I may be infinite, we don't know, we don't care. I may be 10, Y may be alf, Y may be million, zar, sifar, what is the value? 0 only, right? So that is called short circuit. Then the voltage becomes 0. It is. Now this indicates the voltage is 0, but the current could be anything. Current could be anything. That's called short circuit. Means nothing is there. There is nothing. Now, open circuit. Now, an element R is equal to infinite is known as open circuit. Now, let us take this is an open circuit. Means very high value, like insulator, 10 power 12, or maybe very, very high value, 10 power 100, very high value. Then what happens? Current will be 0 because I, if you find I, V divided by R. R is very, very high value. If voltage is small value or big value, something divided by very, very big value, what happens? Its value will be 0. Current will be 0. Okay, voltage may be anything, but R is very high. Then current will be 0. Means it cannot pass in these two terminals. Current will not pass. The charge will not go. Okay, so that is called open circuit. Means cut. There is no junction. There is no connection. When resistance is very, very high. So that is called open circuit. So this indicates that current is 0, so the voltage could be anything. So voltage may be anything, maybe 100 or maybe something. But if R is very, very high, the value of current will be 0. Okay. What is resistor? It may have two values, fixed value and variable value. Fixed resistors. So what is fixed resistors? It is denoted like this. Means there is nothing. Means one material with a length and with a cross-section area and material time, means resistivity rho is fixed, then its value is fixed, it won't change. It's called fixed resistance. Its resistance remains constant and its symbol is capital R. Now what is it has two common type of it has two common types of wire wound and composition. Means it has a wire wound resistance in terms of and a composition type, mixed values, maybe silver or aluminum mixed. So compositions we have. Now the composition resistors are used when large resistors are needed. So we have to increase the value of the resistor. Silver itself, by changing the area, length, it becoming difficult to make our own big value of resistance. Then what happens? You have to mix many things in that, or you have to mix many material in that. It's called composition. Then the value of resistance will increase. Okay, what is a variable resistor? So variable resistor show like this or like this also. These two are the symbols for the variable resistor. One is in the resistor there is an arrow, the saham module. Through the resistor, then it can vary, means it can change. Or you can move the saham in the middle, up and down. It will show like a variable, means it can change the value. If it is down, then it is high resistance. If it is up, then it is low resistance. So this is called variable resistors. A common is known as a potentiometer. This name of this resistor is also known as potentiometer. Actually variable, but it is also known as potentiometer or pot or short. You will study in the lab about this resistance. We have a knob. We can change the resistance. You see in the lab, no problem. With the symbol as shown here. Now, like a fixed resistor, variable resistor can be either wire wound or composition. Here also same thing. If you have small value of resistance we need, it's a wire wound, no problem. Composition if you increase the resistance. The symbol of variable resistance is as shown. Okay, this is about fixed and variable resistance. Now coming to the a useful quantity in circuit analysis is the reciprocal of resistance known as conductance. Now let us say resistance we know. What is resistance? Ability to stop or resist the current. Its ability to stop or resist the current. If it is opposite, what it means? Its ability to allow the current. Its ability to give the chance to the current flow easily. That's called conductance. X of the resistance. Opposite to the resistance is allowing. Resistance is stopping, controlling. Right? Ability to control or stop. But if you take the X opposite side, it allows freely. It's called conductance. So it is denoted with capital G. So resistance already know. Opposite we have to know. It is capital G. So conductance is the ability of an element to conduct electric current. Is measured in mho. Now see, just opposite to the symbol also same. Ohms. If you read in the reverse way, it is mho. Ox opposite. Mho it is called. MHO, also known as Siemens. We have two symbols for the conductance. Either you can use Siemens capital S or Mohs. Okay, Ohms reverse is Mohs. It is symbol you can reverse it. Ohm symbol you can reverse it. Then it is a conductance unit, or you can use Siemens. S is a letter for it. So G is equal to 1 by R, and also given by what is R? V by I. So it becomes G is equal to I by V. Now the same resistance can be expressed in ohms or Siemens. So then it is given by I is equal to GV. What is Ohm's law? V is equal to voltage is equal to IR, current Z R, right? Now what is the in terms of conductance? I equal to V and G. I equal to GV or VG, because R is nothing but 1 by G. Now example, 10 ohms is same as 0.1. What is 10 ohms? Resistance. What is the conductance? X, 1 divided by 10. So it is 0.1 Siemens. The same value. So the power dissipated by the resistor can be expressed in terms of R. The power P is equal to, we already know. What is power in equation? In chapter 1 we studied. V is equal to, P is equal to, power is equal to voltage, Z, current. V multiplied by I. So we already know what is V. What is V? Ohm's law. What is V in Ohm's law? I multiplied by R. So substitute V, I multiplied by R here. So I multiplied by I and R. I square R. This is the first equation. Now okay. As per the Ohm's law, what is I? If V is equal to IR, what is I? V Qasim R. Right? So substitute I is equal to V divided by R. So what happened? V zarb V square divided by R. So we have two equations here. Based upon the current, based upon the voltage. Based upon the voltage, V square by R is the power. Based upon the current, I square R is the power. Now, the power dissipated by resistor may also be expressed in terms of G. No, I don't want in the resistance. I want in the conductance. So what happens? Just substitute R in terms of G. That is, G is equal to 1 by R. R is equal to 1 by G. Wherever the R is there, substitute with G. So when you substitute G here, what happens? V square G will come. When you substitute R is equal to, in terms of G, it becomes 1 by G. So I square by G. So it becomes I square by G, that is R, V square, G it will become. V square multiplied by G it will become. I square by G it will become. Here I put R, I think. We can change this to G, no problem. This is wrong. I square by G, this is the wrong one. I will change it to. Okay, it should be noted in two things from the above equation. What we have two things? The power dissipated in a resistor is a non-linear function of either current or voltage. What is non-linear? Okay, Ohm's law. Is it linear or not? What do you mean by linear? Linear means change something in the same fashion the current other side also will change. It's called proportionality constant. If doesn't have power terms, V proportional to I, it's a linear. If your equation proportionality is power, ज़्यादा मौजूद, I square, I power 3, I power 4 is there, it's a non-linear. It's called non-linear. Now power, okay, V into I, okay, linear. Power is equal to V into I is linear. But in terms of resistance, either I square is there or V square is there. So it is a non-linear term. If we include the resistance in the power, then it is a non-linear. If we include voltage and current, no problem, it's a linear, no problem. But if we want to calculate in terms of resistance, then it is a non-linear because power square term is I square, V square, power is there. It's called non-linear. So the power dissipated, how much power is wasted, is resistor in a resistor is non-linear function, either current or voltage. Maybe current I square R or voltage V square R. It's a non-linear. Second point, since R and G are positive quantities, these are positive quantities, the power dissipated in a resistor always positive. Means resistance is this ability, it's a positive only. So it's a the power is always positive, means it dissipates, not it consumes, it eats. It won't give the power. No, means always resistor will eat the power or consume the power. It won't give anything to outside. Means outside means in terms of voltage current. Thus, resistor always absorbs power, means it will eat the power in the circuit. This confirms the idea that resistor is passive element. Another meaning of what is passive element means this one. Whenever the energy or power is dissipated, absorbed, then it's called a passive element. Incapable of generating energy. So, passive element cannot give the energy outside. Energy means always in the voltage and current form. Cannot give the energy to the world, outside world or in the circuit. Okay, another 5 minutes I will tell. So we have some problems. An electric iron means makua. The electric iron draws 2 amperes at 120 volts. Find its resistance. So R is equal to V by I, or V is equal to IR. This is the Ohms law. Substitute 120 volts divided by current. This is 60 ohms is the resistance. The makua resistance how much? The other one, in the circuit shown, the figure, this is the where 30 volts is the battery or voltage source, and 5 kilo ohms. Kilo means 5,000 ohms. And this is the direction of the current, it's shown, and plus minus, and this is the voltage. This is the items given in the circuit. Now what we need? Calculate current I, conductance, and power P. I we need, we need, and power we need, and conductance G. G means what? Conductance. What is equal? 1 by R. So, wahai taqsim khamsa alf is your conductance. 1 divided by this one 5,000. 1 divided by R is your G. Now, what is I? What is I? It is nothing but V by R. What is V? 30 volts. And what is R? Khamsa alf. So, 30 divided by 5 into 10 power 3 is nothing but 6 milliampere. Because of the kilo will become milli. Kilo will become milli if we go up. So 6 milliamperes. Now conductance G is equal to 1 by R. 1 divided by 5 into 10 power of 3. 1 by 5 is nothing but 0.2. 10 power of 3 become milli. So 0.2 millisiemens or 0.2 millimole. Now power. Equation we already studied. Power P in terms of voltage, V square by R. In terms of current, I square times R. So both you can use, no problem. R power P is equal to VI. We have 3 equations. First one, basic equation, voltage zerb current. Thani equation in terms of current, I square R. Then Talata equation in terms of voltage, V square by R. So power P is equal to VI. 30 is voltage and I is already we calculated 6 milliamperes, 180 milliwatts. Now what is P is equal to I square R. Thani equation. I, how much already you know, 6 into 6, 36 milli, 10 power 6, so minus 6, sorry, 10 power minus 6, 36 into, what is R? R is 5 into 10 power of 3. So this is 180 milliwatts, same. Now P is equal to V square G or V square by R also you can use, both are same. V square G, G already we calculated 0.2 milli and V square is 30 power 2. So we will get 180 milliwatts, same results will come. So our next topic is another example, then we will stop inshallah. A voltage source of 20 sin pi t is connected across 5 kilo ohm resistor, 5000 ohms resistor. Find the current through the resistor and the power dissipated. Now here we need some mathematical equation, trigonometric we can say, derivation or what we call integration. You have to come here. How? Because we have a sine and cosine terms here. So very important now. What is I? As per Ohm's law, V divided by R. V is equal to IR means I is nothing but V divided by R. So what is the V? Which is a 20 sine pi t is already given. What is R? Khamsa alf means 5 into 10 power of 3. So just divide it, you will get the I. No problem. Up to here, no problem. Now what is power? Power is V multiplied by I. So what is V? 20 sine pi t is V. What is I? Arba sine pi t. So 20 into 4, how much? Tamani, right? Then sine pi t multiplied by sine pi t. Sine square pi t. Right? This is your power. Okay? Now let us take a resistor absorbs an instantaneous power of 30 cos square t. Now here, okay. Power is given like sine square t. Here power is given 30 cos square t milliwatt, 10 power of minus 3. When connected to a voltage source, V is equal to 15 cos t. It is square and is 15 cos t. Now find I and R. So how can you find Y and R? Just you have to answer this one. What is I? Based upon the power. Power is equal to VI. Already you know. What is I? Power divided by V. What is power? 30 cos square t milliwatts. Taksim V. 15 cos t. So cos t will cancel. So Wahed cos t will be there. Now 30 divided by 15. How much? Ethane. So ethane cos t milliamperes. Now what is R? R is nothing but in terms of once you know the current 2 cos t. Now R can be found with the equation V by I. R is equal to V by I. So what is V? 15 cos t. What is I? 2 cos t. So 15 divided by 2, 7.5. Cos t divided by cos t will cancel. So it's only 7.5. And because it is I is tahar and milliampere will go, milli will go on the top, it will become kilo, 10 power of 3. So that's why it is 7.5 kilo ohms. So like this we find this one. Okay, next class we'll study nodes, branches and the loops.
Okay, let's start. So in previous class, what we studied about the Ohm's law, we studied resistance, its construction wise and its Ohm's law wise. And what we studied in previous class, uh, chapter 1, we studied about charge, voltage, power, energy, and the current we studied. Now today we'll study about the circuit behavior and circuit construction. So in this, let us take let's take two elements are connected. Let's say two resistors are connected, and one resistance, one source is connected. In source means voltage, current, dependent or independent voltage and current source. And these are connected. How these are connected in series or parallel? So we have to see how it is behavior. So let's take what is node, what is branch, and what is loop. We will study. So a branch represents a single element such as voltage source or a resistor. So what are the items here? The branch. Branch means here maybe a resistor, maybe a source voltage, or maybe a source current, or any source we can say. So this we have a 10 volts voltage source here, 2 amperes current source here, and 3 resistance are there. So as per the definition of a branch, how many branches we have in this circuit? कम are the branches मौजूद? How many branches? I told you branch may be a voltage source or a current source or a resistor. So we have two types of voltage sources. That is, one is voltage source, one is current source, and we have three resistors here. So total, how many branches we have? 5 branches, correct. So because one is voltage source, one is current source, that is the second branch, and 3 resistances we have, that is the 3 branches. Total 5 branches. So branch or element also we can say. Branch or element doesn't mean that only a resistance or only a voltage source. It is a maybe a resistance, maybe a voltage source, maybe a current source. Okay. So any sources or any element may have the item, maybe resistance, inductance, capacitance in future, or maybe a source voltage or source current, or a dependent source voltage or dependent source current. So what is the 5 branches we have? Now what is Okay, these are the different items in this one. Now, what is a node? Now, coming to the node and branches. Now, coming to the node, the connection between two branches is called a node. The connection between two branches is called a node. Like this. Now, if we have a voltage source and resistor, the connection in between two branches is called node, and each branch must have a different value. Like for example, okay, here voltage source different thing, resistance is a different thing. Okay, we can understand. But I have a resistance here and here. Both are resistance only now. We can it can how these can be different here. How means the value means one resistance is 5 ohms and second resistance is 2 ohms. So when these two join together, the junction is called a node. Okay, like 3 ohms resistance and 2 ohms resistance. So when it join together, it's called a node. When current source and resistance join together, it is called a node. Okay, so don't confuse here. If any element have a different value, maybe voltage, maybe current or resistance, then when it join, it is called a node. Now another problem here. What about the item between 2 and 3 ohm resistance? So is this an element or a branch? Between this point and this point is a branch? No, because there is nothing between these 2 points. Nothing. The just silk is there. There is no resistance. There is no source voltage. Nothing is there. So we can join together common node as a. We can make as a common node. Mean we can mix it together when there is nothing between these two fictitious points. That is 1, 2, and 3. In these 3 points, is there anything branch is there inside? No. So we can mix it together. Here also, when there are no elements or no branches in between these points, then we can join together. We can call as a one node. Okay, don't fix as a one node, second node, and third node, and fourth node. No, these 4 points will together is called as a one node because there is no element in between. There is no branch in between. So that's why it is a one node. So I can rearrange this. I can draw like this. See, node A have 5 ohm resistance and 10 volts source, 5 ohms and 10 volts. Now B has 2 ohm resistance, 3 ohm resistance, and 2 ampere. 2 ohm resistance, 3 ohm resistance, and 2 ampere. Now point C are all together connected. 10 volts, 2 ohms, 3 amps, and 2 amperes. This is point C. It is connected with 10 volts, 2 ohms, 3 ohms, and 2 amperes. All are connected together. We can rearrange like that. For looking good in a rectangular form, in a box type, we can draw like this, and we made this as a one node and this we as a one node. So like this is allowed. If you want to rearrange, you can rearrange like this also. No problem. Nothing wrong in that. So definition: a node is a point of connection between two or more branches. I said two. It can be more also. For example, here, how many branches are there? 1, 2, 3, and 4. 4 branches are connected to the node C. For node B, how many branches? 1, 2, 3, 4. Here also 4. 1, 2, 3, 4. Here 4 are there. But for C, we have 5. 1, 2, 3, 4. Yeah, here also 4 are there. Okay. For node A, 2 branches are connected. Like this, the 2 or more branches when are connected, then it is called a node. So in this circuit, we have 3 nodes, A, B, and C. Notice that the 3 points that form B, 3 points that form B are connected by perfectly conducting wire, means no resistance we can say, conducting wire. There is no element in between. And therefore constitute a single point and it is called a node. Now coming to the what is the loop? A loop is any closed path in a circuit. So a loop is any closed path, means there should not be any open circuit in it, then it is a loop. So how? For example, a loop is a closed path formed by a starting at the particular node, at a node we can say, passing through set of the nodes, other node, other node, other node, other node, set of nodes, and returning to the starting node. Means start when you start node 1, then it may go to node 2, node 3, node 4, again come back to node 1, means it must return back to the same node, then it is called a loop, returning to the starting node without passing through any node more than once. So it should not go the other nodes more than once. First node, it can come back, that is called coming back, means completing the circuit. and the other node should not be more than once. Means I go to the 1, 2, again 3, again come back to 2 and 1. No, it has to go to 1, 2, 3, maybe 4, then come back to 1. First node you can come back, but not the in between node again. That's called not more than once. For a loop is said to be independent, means independent, not depending on others. If it contained at least one branch which is not a part of any other independent loop. Means independent loop means a loop is we having and which is not involved in the beside loop. Means if we have one set of branches and other set of branches connected together, and one particular point will come, there is a resistance or something which is sharing these two loops. So this is not independent loop. This is a dependent loop, we can say. You can show the example. Independent loops or paths result in independent set of equation. Independent loops always have a independent set of equation. Then we can solve the those equations. We can get the results. Okay, a network with B branches. Look, branch we call B, small b, nodes with small n, and loops with small l. Loop will satisfy the fundamental theorem of network topology. What is topology? It's a construction. It's a what do you call topology means it's picture. We can say topology. Network picture with an equation B equal to L plus n minus 1. L plus n minus 1. So next one, okay. Now, what is B here? Branches. L is loops and N is nodes, minus 1. Now, coming back to the previous case, what we have? 5 branches, right? We already checked. Now, let us take how the 5 branches are there. We can see. Number of loops we found there 2. Then number of nodes already we know there A, B, C, 3. Minus 1. 2 plus 3, how much? 5. Minus 1, sorry. Number of nodes A, B, C. Right. C, 3 nodes are there. And number of loops formed is 2. 5 minus 1. So number of branches will be 4. So we can see the previous example or another example we can see. Okay, 2 or more elements are in series if they exclusively share a single node and consequently carry same current. So 2 or more elements in series, 2 or more elements in series, if they exclusively share in a single node, if they have single node, then they carry same current. Means it will say that we have a series resistance where the current will be the same. 2 or more elements are in parallel if they are connected to the same nodes and consequently have the same voltage across them. We'll see with the topology, then we can understand what is meaning this one. For example, this one. So how many branches we have here? 1, 2, 3, 4 branches. Understand? How many nodes it is formed? You have to tell. How many nodes are there here? 10 volts and 5 ohms form one node, A, let us say. 5 ohms and 6 ohms form one node with 2 ampere current. Second node, common node here, B. Now, 2 ampere, 6 ohms and 10 volts all together will form another node. How many? 3 nodes. So, A, B, C, 3 nodes we got. So, 3 nodes we got it, right? Now, how many loops we can have? One loop, this one, that is 10 volts, 5 amperes, 6 ohms and 10 volts come back. So, we are starting from here and coming back, one loop. Now starting from here and coming back 6 ohms and 2 amperes and come back, second loop. So we have 2 loops and 3 branches, 3 nodes, ABC 3 nodes and 2 loops. How many? 5 minus 1. How many branches? 3 plus 2, 5 minus 1. How many branches? 4 branches. So see, 4 branches are here. The equation we are satisfying 1, 2, 3, 4 branches. The topology equation is we are satisfying here. So determine number of branches and nodes in the circuit. Identify which elements are in series and which are in parallel. Okay, now which are in series? I told you that if a node is commonly sharing only 2 branches, then it is called in series. Only 2 branches are there. So 10 volts and 5 ohms are in series. What about the 5 ohms and 6 ohms? Is it in series? No, because this node is sharing how many branches? 1, 2 and 3 branches. So these are not in series. Okay, so like this series parallel we can understand. If a node is sharing two elements common, then only two elements in common, then those two branches are called in series. If these more than two branches are connected to a node, then it is called parallel. Okay, you can see here. So 1, 2, 3 is the nodes. Now you can write here. Since there are four elements in the circuit has four branches, 10 volts, 5 ohms, and 2 amperes. The circuit has three nodes, A, B, C, or 1, 2, 3, we can say. 5 ohm resistor in series 10 volts, 5 ohm resistor in series 10 volts because the node 1 is sharing these two branches. Same current would flow because these are in series, same current will flow in these two. Okay. The 6 ohm resistor are in parallel with 2 ohms resistance because this is sharing, the node 2 is sharing with 5 ohms, 6 ohms, and 2 ampere. So, and both are connected in node 2 and 3. Both are connected in node and 2 and 3. Okay, now coming to now, how many branches and nodes does the circuit have? Identify the elements that are in series and parallel. Okay, this one. Now you have to answer this. Answer this one. How many? Forget about branches. Now think about the what we call nodes and loops. So nodes. 1 ohm, 2 ohms, and 5 ohms sharing this one, first node. 5 ohms, 10 ohms, 4 ohms sharing this node, second node. And this down, all are the together. These are called third node. How many nodes? Three. Remember. Now, how many loops can form? Loop means closed circuit. So, if you take 1 ohm and 2 ohm, this is first loop. One coming to the two and coming to here and coming back. First loop. And 2 ohms, 5 ohms, and 10 volts. How many loops? One loop. That is 2 ohms, 5 ohms, 10 volts, and coming back to the 2 ohms. That is second loop. Now another loop. 10 volts, 4 ohms. This is another loop. Starting from here, go to the 4 ohms, come back, and come back to the 10 volts. So another loop. So how many loops we have? Three loops and 1, 2, 3 nodes. So three loops, three nodes minus one is number of branches. Check it is correct or not. So three loops plus three nodes, six minus one. How much? Five. So check how many five branches are there. One, two, three, four, five. Correct. So our answer is now satisfied. Last answer for this question is how many are in series and parallel. Now see for this node, 1 ohm, 1 ohm, 2 ohm, and 5 ohms, three are connected. So, is there any series here? No, three are connected. So, there is no series here. Now, second node. For the second node, 5 ohms, 10 volts, and 4 ohms all are connected here. So, no series. And the down one, all are connected. So, no series. Is there any series element here? No series element. All are in parallel. So the 4 ohm 10 volt source is in parallel. 1 ohm and 2 ohm series in parallel. All are in parallel, no series. So we can answer like that. So this is another example. Now coming to the laws. Another law. Ohm's law we already studied. V is equal to IR. Voltage is proportional to current and the proportionality constant is resistance. And resistance equation is rho L by A. And the resistivity will change depend upon the material. Length and area also affect the resistance. Now another law is called Kirchoffs law. So we have two laws in it, Kirchoff's current law, Kirchoff's voltage law. First we will study the Kirchoff's current law. Ohm's law by itself is not sufficient to analyze circuit. So Ohm's law we know V is equal to IR. For each element V is equal to IR, V is equal to IR, we cannot solve that one. Complex, as the complexity of the circuit increases with series, parallel things are coming, we cannot solve with the Ohm's law. So for that we got two more laws is called Kirchhoff's current law and Kirchhoff's voltage law. However, when it is coupled with Kirchhoff's two laws, we have sufficient and powerful set of tools. So we got three laws, then we can have easy solution and easy steps to follow. These laws are formally known as Kirchhoff's current law and Kirchhoff's voltage law. So what is Kirchhoff's current law? Kirchhoff's current law, current means moving part. Current, voltage means potential difference between 2 points. Current means moving. So Kirchhoff's current law states that the algebraic sum means maybe plus or minus, algebraic sum we call, plus or minus, algebraic sum of currents in a node or a closed boundary is zero. Means for a particular node A, if three branches are connected, the currents entering and leaving together, Jama, is equal to zero. Means law of conservation of energy. Means energy neither created nor destroyed. It can be transferred or consumed. Right? So, the current entering must equal to the current leaving also we can say. Means at a particular point, the total current is zero. Means one point from one line, the current is coming. From other two lines, the current may be going. But these together is called zero. Okay, so how we can see where in is equal to 0, n is equal to 1 to n, and in is equal to 0. What is I is current, and what is n? Node. Means the node number. For at that node, the sum of the currents from n is equal to 1 to n, means current n1, I1, I2, I3, I4 in coming to that node. Node lines, we can say node lines or node branches. Branches, n is the number of branches also we can say, where n is the number of branches, capital N is the number of branches total, and connected to the node in, first node I1, first node I1, number of branches is n. So nth current entering or leaving the node. We can see the example. The above equation is another form of KCL. What is the above equation? Just see, yeah. Okay, before going to that, see here. So this is the node. I can say one node. How many currents are there total? 5. How many branches connected? It means 5 branches connected. 5 currents are there. Kamsa currents. So how many currents are there entering, moving inside to the node? I4 is moving inside. I1 is moving inside. I3 is also moving inside, Juva, right? Now, how many barra? I2 and I5. I2 is outside and I5 is outside and I2 is outside. So, 3 is inside coming and 2 is outside going. So, what is the equation as per Kirchoffs current law? The sum of these all currents equal to 0. How can we form this one? So, we can have a algebraic sum, means one direction take as a positive, other direction take as a negative. Let's take coming inside positive. What are the positive? Inside I1, I3, I4 are positive. So sum it. I1 plus I3 plus I4 are the Juva inside coming. Next, I2 and I5 is going outside. So take it as a negative. So minus I5 minus I2 equal to 0. So if you rearrange this equation, how can we write? I1 plus I3 plus I4 is equal to I2 plus I5. Means the current joining together, coming inside, joining together is equal to the current leaving from that node, sum is the Kirchoff's current law. Just check here. How can you write? I1, direction I told you. If it is correct coming enter, take it as positive. Next, I2, what is happening? Going outside, minus I2. Plus I3 coming inside, no problem. I4 coming inside, no problem. I5 going outside, so minus. So equal to 0. Now rearrange this I2 and I5, it will go other side of the equation. Then I1 plus I3 plus I4 is equal to I2 plus I5 on other side. So I1 plus I3 plus I4 is equal to I2 plus I5. So sum of current entering a node is equal to sum of current leaving a node. We can say another definition. Okay, algebraic sum of the currents at a particular node equal to 0. One definition. Tani definition: sum of currents entering a particular node is equal to sum of currents leaving that node. Is the second definition. We have two definitions for Kirchoff's current law. Both are correct. The sum of currents entering a node is equal to the sum of current leaving the node, the same node. Be careful here. Now here I can rearrange node A and B is there. How many currents are entering here? 1, 2 and 3 not entering. Total currents are here 3 currents. So I can write I1 is entering minus I2 plus I3. So I can write with a single current as a I total, which is equal to I1 minus I2 plus I3, which is IT. I can rearrange with this also. Here how can I rearrange with this one? I1 plus I3 plus I4 minus I2 minus I5. Here I can write. A simple application of KCL, a combining current sources in parallel. These are in parallel because the same node we are connected three different currents, so it is a parallel. For the same node, only two are connected in series, not sharing with the other node. Then it is a series. For example, the current sources can be combined. Okay, IT is equal to I1 minus I2 plus I3. What we mentioned here. Okay, a circuit cannot contain two different currents I1 and I2 in series unless I1 equal to I2. Otherwise, KCL will be violated. Now let us take two branches are connected to a single node. The current is in these two branches is same, and for that particular node, I1 and I2 is equal. I1 is equal to I2. Then it is called I. Because in the same series circuit, current cannot be different. In series circuit of two branches or more branches in the series circuit, the current will be same. I1, I2, I3, I4 for each branch is equal. Otherwise, there is no series in the picture. Series means the current will be same. Okay, unless I1 is equal to I2 means let's say four branches are in series. Now first branch I1, second branch I2, third branch I3, fourth branch I4. So what is the total current I? Is nothing but I is equal to I1 is equal to I2 is equal to I3 is equal to I4. All are equal. If all these I1 to I4 are not equal, then these are not in series. That is the link means. Now, second law, Kirchoffs voltage law. Kirchoffs voltage law. Kirchoffs voltage law states that the algebraic sum of all voltages around a closed path or a loop is zero. So, it is quite opposite. Here we have to think about the loop. The previous one, Kirchhoff's current law, think about the node, the elements, branches connected to a particular point, node. Here, the closed circuit we have to call. Means number of elements connected in the closed circuit. It is called loop. So in that loop, that voltage drops or voltages is equal to zero. Algebraic sum here again, maybe minus or plus. Algebraic sum of all the voltages must be zero. So we'll see here. Let us take, now I told you in the chapter 1, I think, this chapter only, no, chapter 1, I think. The current entering a positive, then it is called power dissipated. Current entering positive, then it is called power dissipated. Current leaving the positive, we have to take as a power given, power generated or given. So when current leaving a positive, we have to take that as a minus V. If current enters a positive, then we have to take as a plus V. Understand my point? Now here, see the loop. This is the loop. The current I formed, I assume the current direction is like this. Current direction is like this, clockwise. Okay. Now from the voltage V1, current is leaving from the positive. Then I can assume it. I can take it as a minus V1. Now current entering to this V2. Current entering, I will take it as a positive. When the current enters a element or a branch, then we will call it as a positive V, positive voltage. So positive V. Now current also entering in the resistance. This is V3, second this element or branch. Then also V3 plus V3. Now current leaving the positive. Same like this. Leaving the positive. So it should be minus because leaving the positive. Now current here entering the positive plus V5. So like this, we have to be careful here. It's not a big deal. Just remember when current enters a positive, take that component as a positive V. If current leaves from that positive, then that component take it as a minus negative V. Okay. So we can write. Okay, terminology. Okay, clockwise. Yeah. So I told you minus V1 because current leaving, plus V2 because current entering, plus V3 current entering, minus V4 current leaving, plus V5 current entering, equal to zero. So it's a algebraic sum of, means sum plus or minus, algebraic sum of all voltages in a loop is equal to zero. or you can rearrange this one. If you rearrange, take the minus terms to other side, what happens? Plus V2 plus V3 plus V5. That is V2 plus V3 plus V5 equal to minus V1 go this side, minus V4 go this side. So it becomes again plus. So V1 plus V4. So what it means? The voltage drops in the V2, V3, V5 is equal to voltage rises in V1 and V4. What is V1 and V4 generally? Can you see from the picture? What is V1 and V4? These are the power sources or voltage source. Source means giving the power, giving the voltage, we can say. Okay. So giving things are other side, taking things are this side. So this is called the balance. Okay. Law of conservation of energy also satisfy here. The voltage drops is equal to voltage rises. You can say voltage rises means giving. Voltage drops means taking, like this. Okay, this is an alternative form of KVL which may interpret as what it means. Sum of voltage drops. These are the voltage drops. Sum of voltage drops equal to sum of voltage rises because these are the voltage sources. Sum of the voltage eating, this is drops, is equal to sum of the voltage rises, that is giving. So let's have when voltage sources when voltage sources are connected in series KVL can be applied to obtain a total voltage. If these are voltages connected in series, then voltages can be joined together, no problem. But in parallel, for example, V1 is connected and V2 is connected, V3 is connected between node A and B. Okay, here another two nodes will come because these V1, V2, V3, how much we don't know. If V1, V2, V3 are same, there is no node between. But V1, V2, V3 are different, then there is another node here. But our aim is what is the voltage between A and B? And this voltage is sharing this V1 and V2 sharing with a common node and V3 and V2 sharing common node. So these are becoming series. So what happens? Current, as per the current entering, all are same. But here current is leaving. When you observe the current loop here or you form a current entering here, so plus V1 current entering, plus V2 current here leaving, minus V3. So total voltage can be Vs is equal to V1 plus V2 minus V3 between point A and B. Between point A and B, that is VAB, can be rearranged with voltage source Vs, means source voltage, we can say. These are some of these three voltages, not directly V1 plus V2 plus V3. No, we have to see this convention or polarity, plus minus, plus minus, plus minus. This is minus plus. So current enters means V1 plus V2 minus V3. So like this we have to write. That is also we can say we minus VAB. If you write the convention, what is here total? Minus VAB as per the loop. As per the loop, minus VAB because the current leaving the positive terminal, minus VAB. This VAB is minus. Now plus V1 current entering, plus V2 current entering, minus V3 current leaving. So minus V3. Now rearrange this. VAB is equal to V1 plus V2 plus V3 or V1 minus V3. To avoid violating KVL, a circuit cannot contain two different voltages V1 and V2 in parallel unless V1 and V2 are equal. So in parallel two branches are there, parallel. In parallel two branches are there. These two branches have equal voltage. No different voltage. If first branch is V1, second branch is V2, then the total branch voltage of these two parallel is V is equal to V1 equal to V2. Then only it is called a parallel. Opposite in series, what happens in series? Series two resistance or three resistance are in series, then the current in that series is nothing but I, which is equal to I1, equal to I2, equal to I3. All three currents are same, equal. Then only the current will in series is same. And parallel, V1, V2, V3, V4 are all are equal, and that voltage is V, we can say, in parallel. Now coming to the examples. For the circuit in the figure, find V1 and V2. What is V1 and V2? We have to find. So 20 volts is the source voltage and 2 ohms, 3 ohms and V1 and V2. Okay. Now by assuming we have a closed circuit, we can form one equation. KVL we can apply here because three are in series. There is no parallel here. Check here. Is there any element or branch in parallel? No. All are in series. So when all are in series, then which thing we can add here? Kirchoffs voltage law. Because there is a formation of a loop. When there is a loop is formation, we can have a Kirchoffs voltage law and Ohm's law. Ohm's law is by default. Okay. Now let's take draw the KVL, Kirchoffs voltage law equation here. So what is the Kirchoffs voltage law? Assume a clockwise direction of the current, clockwise. So current is leaving from 20 volts. What it should be? Leaving plus. Current leaving plus means minus or plus. When current go out from the positive terminal, the value of the voltage should be minus or plus? Minus. The current entering this 2 ohm resistance positive, then what it should be? Plus. The current leaving from this positive, what it should be? Minus. So how can I write? 20, that is minus 20 plus V1, then minus V2 equal to 0, right? So that is minus 20 plus V1 minus V2 equal to 0. Now what is V1? V1 is nothing but we can write Ohm's law. The current, total current here is I. So what is the Ohm's law? V1 is equal to IR, 2 into I. What is Ohm's law current here? V2 is equal to 3 into IR, right? Substitute here, solve the equation, you will get the answer for the what is V1 and what is V2. Check here. So V1 is nothing but, what is V1 in Ohm's law? 2 into I. And V2 in the Ohm's law, because current leaving, so minus 3I, current leaving, here current entering, right? Current leaving here, so minus 3I, V2. Now applying Kirchoffs voltage law, minus 20, minus, plus V1, minus V2, minus 20 plus V1 minus V2 equal to 0. Now substitute 2I here, now substitute minus 3I here. What happens? Yes. So the equation will be minus 20 plus 2I plus 3I. Now I can find easily, that is 5I. So 20 will go that side. I equal to 20 divided by 5. How much? 4 amperes. So I got 4 amperes. Now what is V1? 4 into 2, 8. 4 into 2, 8 volts. What is V2? 4 into 3, 12. So minus 12 is the voltage here. Minus 4 into 2, 8 volts. 8 volts and 12 volts. Minus 12 volts here is the voltage. So like this we have to find the voltages and currents by using Kirchoff's voltage laws and Ohm's law. Two laws if you apply, then only the result is coming. Only KVL will not give. Only Ohm's law will not give the result. Both together it will give. Now let's take another example. Determine V0 and I. V0, where is the V0? We have to see the circuit, and I in the circuit. Where is the V0? This one. Why it is V0? Because it is a dependent voltage source. Dependent voltage source is there here. So V0 we want here. Now same KVL we have to apply here. And Ohm's law. What is Ohm's law? Current I. V1. What is here? 4I. Okay. Now here current leaving. Current entering here. Leaving means minus 6I, which is equal to V0. Now apply the loop equation. Minus 12 because leaving plus 4I or V1 we can say, or plus 4I. Current entering. Now here current entering plus 2V0 plus 2V0. Current leaving minus 4. Current leaving minus V0. 6I also we can use, or V0 also we can use. Okay. So solve the equation with in terms of V0 and I, we will get the result. Check here. So minus 12, that is this one. Plus 4I, this one, and plus 2V0 because current entering, plus 2V0, this one, minus 4 because current leaving, minus 4, plus 6I, current, there is 6I. Something wrong here. Current entering, it should be right. Yeah, plus 6I. 6I. Okay, we'll see why it is plus 6I is coming. Okay, now applying Ohm's law to V0. What is V0 actually? That's why it is plus 6I, correct. So V0 is now how much here? Current leaving. So minus 6. So minus of minus here plus is coming. Actually, it is minus V0. But what is V0? Minus 6i. So minus of minus plus 6i. Okay, don't confuse here. That's why this equation should be in the top actually. Then it will be easy. That's why you will getting confused here. No problem. Now substitute what is V0? Minus 6i. That is here also. That is minus 12. So minus 12i and plus 6i and 4i. 6 4 10 minus 12. So plus 10i minus 12i minus 16 because it is minus 12 minus 4 minus 16. So we'll get one equation I equal to minus 8 ampere. Now V0 is equal to minus 6 into I, that is 6 into minus 8, 48, minus of minus plus, that is 48 volts. So like this we have to find the another example we have. Yeah, last example. Yeah, another example you see. Find current I0 and voltage V0 in the circuit. Now here another method. Now previous two examples what we studied, Ohm's law must and Kirchoffs voltage law must, loop voltage law. Now here all are in parallel. Two loops are there, but there is a node. Means node is important. Okay, node we can use. Find current I0 and V0 in the circuit. Applying KCL, Kirchoff's current law at this point. Because many currents are there, we apply Kirchoff's current law. Many voltages are there, we apply Kirchoff's voltage law. So current is entering to this node is 0.5 I0 at that point, current leaving I0 and current entering 3 amperes. So three currents are there, two are entering and one is leaving. I can write 3 that is entering 3 amperes plus 0.5 I0. This is also entering, which is equal to outgoing, which is one I0 is outgoing. So this is the one equation. Now, what is I0? From this equation, I0 can be found as, take out this here, 1 minus 0.5, 0.5, right? So 3 divided by 0.5, it is 6 amperes. Solve this equation. 0.5 will go this side, it becomes minus 1 minus 0.5, that is 0.5, which is equal to half, no, 1 by 2. So 1 by 2 will go this side to the 3 into 2 is 6 amperes is the current. Now once we know the 6 amperes, now what is the 4 ohm resistor? 4 ohm resistor, what is V0? Is nothing but current multiplied by resistance. V is equal to voltage multiplied by resistance, Ohm's law. So 4 into I0, that is 4 into 6, 24 volts. So like this, we find the node voltages. We can find with the node voltages. Find the currents and voltages in the circuit 2.27. Another one. At this point, current entering I1, current leaving I2 and I3. So I can write I1 equal to I2 plus I3. Can you write? Yes or no? At this point A, current entering I1, which is equal to I2 and I3, which is I2 plus I3. Now write the Ohm's law. What is V1? 8 into I1. What is V2? 3 into I2. What is V3? 6 into I3. We got Ohm's law, we got nodes, and we need another also. Still not sufficient. We need another one. Kirchoff's voltage law also we need here. That is loop equation. Let's see. Loop 1, loop 2 will form. That is loop 1, what is the equation? Minus 30 because current leaving. Minus 30, current entering. Plus V1, current entering. Plus V2, then here in this loop, current leaving, right? What do you mean by current entering? Sorry, I2. This I2, that is V2 plus current entering I3 plus V3, V2 plus V3. But what is V2 and V3? These two are in parallel. So the V2 is equal to V3. It will be there. V2 is equal to V3 because as per the loop, current is leaving from this negative terminal. So it is V3 and current is entering in the positive terminal in V3 is positive and current leaving the V2. So minus V2 plus V3 equal to 0. So V2 equal to V3 we can say. So let's see this one. So V1 already I know, I told you what is V1. V1 is 8 I1, V2 is 3 I2, V3 is 6 I3. 8 I1, 3 I2, 6 I3, we know it. Now coming to the, since the voltage and current of each resistors are related to Ohm's law, then I can write I1 minus I2 minus I3 equal to 0. Also, I1 equal to I2 plus I3. I1 equal to I2 plus I3. Now, applying KVL in first loop, minus 30 plus V1 plus V2 equal to 0. So, substitute what is V1? 8I1. What is V2? 3I2. Substitute here. Minus 30 plus 8I1 plus 3I2 equal to 0. Now, in this equation, two are different. I1 and I2 are there, but I don't want that one. I want in terms of other things. I can rearrange this one. What is I1? I rearrange this one. What is I1? So, 30 take that side and 3I2 take that side. So 30 minus I2, 30 minus 3I2 divided by this 8 will go out. So I1 is 30 minus 3I2 divided by 8. One equation in terms of I1, I2, I got it. Now apply second KVL. So this is minus V2 because current is leaving from that. So minus V2 plus V3 current entering. So plus V3 equal to 0. That is V2 equal to V3. Now substitute what is V2? 3I2. What is V3? 6I3. So 6I3 equal to 3I2. Now what is I2? What is I2 we can find? Or I3 you can find. I3 is equal to 3 divided by 6. That is 1 by 2 I2. Or I can say I2 is equal to 2 times I3. You can substitute here 2 times I3 also. No problem. Okay, later we'll see. Now substituting these two equations. That is 30 minus 3I2 divided by 8 minus I2 in this equation. In this equation, what is I1? This one. My 30 minus 3I2 by 8 I1. What is I2 minus I2? As it is, don't change it. Now what is I3? Minus I3? I2 by 2. That is minus I2 by 2. Now solve only I2 is there in this equation. You can solve the equation from the calculator also you can do it. You can get the I2 as 2 amperes. Now once you know the I2 2 amperes, substitute here. I3 will be 1 ampere. Substitute here. I2 equal to 2 amperes. 30 minus 3 into 2 how much? 6. 30 minus 6 how much? 24. 24 divided by 8 how much? 24 divided by 8 3. So I1 is 3 and I3 is 1. Now if you know the I1, I2, I3, what is V1? 8 into I1. 8 into 3, 24. What is V2? 3 into I2. What is I2? 2. 3 into 2, 6. 6 volts. What is V3? 6 into I3. What is I3? Here is I3. Yeah, I3 is 1 ampere. So 6 into 1, 6 volts. So we got all the voltages, all the currents, everything we got it. Okay, we'll stop here. Next class we'll study about another example. Yeah, series parallel voltage division study in the next class. Okay, let's start. So our next topic is series resistor and voltage division. In previous classes, we studied many things, chapter 1 and chapter 2, like charge, voltage, current, power, energy, we studied. In chapter 2, we studied about the resistance by its construction, Ohm's law, and Kirchoffs voltage law, Kirchoffs current law, we studied. 3 laws we already finished, 2 Kirchoffs laws and 1 Ohm's law. Now let's study about the series and parallel combination of the resistors and star and Y-delta and delta and star combination of the resistances. Now first start with the series resistor and voltage division. I already told you series when resistors are connected in series means jama together means a node is sharing only two resistors. A single node sharing only two resistors, not three. Then these two are called in series. Then that resistor will have a voltage division. When two resistors are in series, that it will have a voltage division. How we will see now. Now see here. See here the resistor 1 and resistor 2 are connected in series with a voltage source. And voltage source is also connected in series with R1 and R2. So all are in a one loop and all are in series. How we can say it is in series? See, for this node A, the whole element A, V or branch also we can say, element or branch, voltage V and V1, both are in the same node. No other division is there in that node, means not more than two are connected. So, and other node of means V1 other node is this and V other node is B. So these two are not of the same branch. If the same branch is sharing two same nodes, then it is a parallel. If the node is not sharing the same branch, then it is a series. Like V1 and V2, it is not sharing the other node. So this node is only sharing V and V1 only, not more. Or I can say R1 and R2. It is showing this here. If you keep the node, R1 and R2 sharing only a single node, not more than this. So these are in series. So R1 and R2 can be assumed as a series. Okay, consider the single loop circuit, this circuit I'm telling. The two resistors are in series since the same current flow, because this is a loop and there is no current division here. There is no division in current in the nodes. But why? Because it doesn't have more than two branches to that node. If we have more than two branches in that node, there is a current division. So here two branches are there. So and this node also two branches, and this node also two branches. So the current will be same in complete this loop. Okay, applying Ohm's law to each of the resistor. Now apply the Ohm's law to this one. What is V1? This I into R1. This current entering the positive terminal, so plus I R1. And what is V2? Current is entering the positive terminal here, so plus I R2. So we know that one already by Ohm's law. Now if I apply KVL, loop equation, we apply here KVL moving clockwise. So start from the voltage. Current is leaving out, going out from the plus terminal. So it is minus V. Now current is entering to the plus terminal here. It is plus V1. Here also current entering this plus terminal. It is V2. It's the summation of all the voltages, algebraic sum of all the voltages equal to 0. So all three voltages already we add as a sum equal to 0. V is Y minus because current leaving from the plus terminal. So these two Ohm's law we got it, and KVL we got it, Kirchoffs voltage law. Now combine these two equation, substitute what is V1, what is V2. So V I will put on other side, and what is V1 and V2 I will put IR1, then IR2. In IR1 and IR2, I is common because I is same. So I, if you take out R1 plus R2 will left out. So I times, that is I observe R1 plus R2. So what will be the current I can be, what is the current I equation can be written as total voltage, that is source voltage, V divided by R1 plus R2. So what is R1 plus R2 here? It is the sum of the total resistance R1 and R2 is nothing but sum of the complete circuit resistance, we can say. This is equal to equivalent resistance, I call it R equivalent, which is equal to R1 plus R2. That is, we call it as series. When things join together without any problem, it is called in series. Okay, notice that this equation can be written as V is equal to, that is V is equal to I R1 plus R2. This R1 plus R2 I will write as a R equivalent, means R total, R Jama we can say, R equivalent. Now, implying that the two resistors can be replaced by an equivalent resistor, means without, don't need to write every time R1 plus R2, just replace this R1 plus R2 with R equivalent. So R equivalent is given by R1 plus R2. So I can redraw the circuit with this R equivalent resistance. No need to draw the two resistances here like this. No need to draw like this. Only one resistance we can draw. Voltage will be V. Then total voltage. This V is equal to this V. How? Because this branch and this branch will share same nodes. See, first node, okay, it is sharing. That is V and resistance. It is sharing the node A. I can think that it is maybe series. But think, see the other node. The B node is also sharing same branch. So when the two nodes are sharing same branch, then it is called a parallel. So this voltage source, now resistance is now in parallel. Now when there is a parallel, the voltage what it is here, V, which is equal to the voltage absorbed by the resistor here. So V, that is V is equal to IR equivalent. So V is here now. The same V will come here. So we have to remember here that voltage in parallel is same. Current in series is same. So these two things you have to keep in mind. current in the series is same. Voltage in the parallel branches are same, or we can say equal. Okay. The two circuits in figure 2.9 and these two circuits are equivalent because they exhibit the same voltage current relationship at the terminal A and B. At terminal A and B, same voltage and current relationship which will is behaving. So V is nothing but I times R equivalent, which is nothing but R1 plus R2. Okay, now coming to the series resistors and also okay. The equivalent resistance of any number of resistors connected in series is, what is the equivalent resistance of any number of resistors? Now he talked about only two resistors. Let's say I have more resistance in series. Then what is the equivalent resistance will come out? So if we have two resistance in series, what the equivalent resistance we got? R1 plus R2, just Jama, right? Same rule will apply is the sum of the individual resistances. How many resistances may be? If they are in series, then just Jama it means R1 plus R2 plus R3 plus up to R infinity. So that can be given as, for n resistors, if we have, we can write R equivalent is equal to R1 plus R2 plus dash 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 Rn. Okay, all should be just join it. If conditions, they must be in series. Now I can write in mathematical equation format in the sigma n is equal to 1 to capital N, that is number of resistances, and Rn. So Rn means one resistance. So if we expand this sigma, Rn will become R1 plus R2 plus R2 plus R3 dash dash R capital N it will become. If we have 10 resistances, N equal to this capital N is 10, then the equation will be R1 plus R2 plus R3 plus up to R10 it will come. So like this, series means R1 Jama, R1, R2, R3, R4 Jama. Okay, now voltage, because we cannot stop only series just Jama resistance. We have to see the current and voltage. Current we already know. If the series is there, current is same in all the resistances. If the series is there, current is no change. First calculate the current by source voltage divided by total resistance. You will get the current. And this current is common for all the resistances. Only the problem now, voltage you have to check. In each resistance, what is the voltage? So to determine the voltage across each resistor, how much voltage? Current we know it is same. Okay. Now we substitute equation 2.26 and 2.24 to obtain. Just check. V1 equal to R1 by R1 plus R2 V. V2 is equal to R2 by R2 plus R1 plus R2 by V. Now what is R1 V? What is V1 as per the previous equation? V1 is equal to I R1. You know, in previous, just we can go to the previous slide if you want, I will go it. So what is it? V1, I, R1. Now what is I? Already we got equation. I is nothing but V divided by R1 plus R2. Just remember this. V divided by R1 plus R2 multiplied by R1. So put R1 this side, V other side. So R1 by R1 plus R2 times V. So we can put like that. See here, V I put other side means in the ZERF, and R1 by R1 plus R2 I keep it here. So what you understand here, the voltage across the first resistance is nothing but its own resistance multiplied by total voltage, total applied voltage divided by Taksim Kullu resistance means Jama Kullu resistance. So how can we know? I R1 is. What is the voltage across the resistance 1? I R1. What is I? Total voltage divided by total resistance. Or voltage divided by total resistance. So V Taksim total resistance is R1 plus R2. What is the ZERF? R1, Ohms Law. R1 multiplied by I. I is nothing but V by R1 plus R2. So what you observe here? So current multiplied by R1. So R1 by R1 plus R2 is your ratio of the voltage in first resistance. Now second one, for resistance 2, same. Its own resistance divided by the total resistance is the ratio of the voltage in the based upon the total voltage. What is total voltage? V. What is the ratio? Means its own resistance divided by total resistance. It will give ratio. What you call ratio? Percentage you can say. Okay, percentage you can say. So that much percentage of that voltage is at R1. That much percentage of voltage is at R2. So that like this we have to calculate. Now how the definition we can write. The voltage division is defined as the source voltage, the complete source voltage V, being divided among the resistors, R1, R2, being divided among the resistance R1, R2. If more are there, all will come in picture. Resistance being divided among the resistors in directly proportional to their resistances. So V divided by R1 plus R2 is current. Multiplied by R1 means it's directly proportional to its own resistance. If resistance R1 increase, the voltage drop increase. Its own voltage drop increase. If resistance decrease, the voltage drop will decrease. So it is called directly proportional. It will quite opposite parallel resistance, inshallah. We'll check it. Okay, the larger resistance, the larger is the voltage drop. Now let us take. We have R1 Ashra and R2 Ashreen. And total voltage is, let us take Talatin. Talatin is a source voltage. R1 Ashra. R2 is Ashreen. So what will the total resistance? R1 plus R2. R1 Ashra, R2 Ashreen. So total is 30. Whatever. Come on, this is becoming a problem. Okay, so the voltage division is defined as the source voltage V being divided among the resistors in direct proportional to their resistances. The larger the resistance, the larger the voltage drop. So I was discussing if resistance is Ashra and Awwal and Thani resistance is Ashreen and total voltage V is Talatin. So what is happening here? What is the total resistance? Is nothing but sum of the all resistance. Awwal resistance Ashra, Thani resistance Ashreen. What is R equivalent? Talatin. 10 plus 20, Talatin. Now what is total current? I equal to Ohm's law. Total voltage, Taksim, total resistance. What is it? So total resistance is Talatin. I told you voltage is also Talatin. So Talatin, Taksim, Talatin come Wahed. So what happens? Wahed ampere is the current. Now what is the Awwal resistance voltage? Ohm's law. Awwal resistance voltage is nothing but IR1. R1 is 10. So 10 into 1, how much? Ashra volts. Thani resistance voltage, IR2. So R2 is Ashreen. So Wahed is ampere and Ashreen is the resistance. So Ithnane. So Ashrin volts. Awwal is Ashra volts, Thani is Ashrin volts. So what you understand here? If the resistance is more, the voltage is more. Ashrin volt, Ashrin ohms, and Ashrin volts. Ashra ohms, Ashra volts. Hada voltage. Awwal resistance, Ashra volts. Thani resistance, Ashrin volts. Because more resistance, more voltage. Less resistance, less voltage. That's why it is telling the larger is the voltage. The larger is the resistance, the larger the voltage drop. So we have to understand it is called directly proportional. Okay, next. Parallel. Series class, what are the series? Just I was rewinding to three things. One is series. How we know it is in series? If a node is sharing two branches or two resistances only, and the other node should not share the same branches. Two conditions are there. How we can find the series as per the topology. How the topology means that structure by seeing the picture. How we can know the node of that resistances should be only two for that node, not more than that. And these two resistances must not share the other node. These two resistances must not share other node. Otherwise, this becoming parallel. Okay. So first condition. Second condition, if these are in series, all resistance should be Jama, means sum of all resistance is equal to equivalent resistance. Second condition. Second rule. Third one, voltage will be voltage drop we call. Voltage across in each resistances is will be more if the resistance value is more. If three different types of resistance are there, one is more, one is medium, one is small, then the small resistance will take smallest value of the voltage, medium resistance will take medium value of the voltage, and maximum resistance will take maximum value of the voltage, which is called directly proportional. So these three rules you have to see. You can remember. Parallel. Now coming to parallel, just quite opposite. If the two branches are sharing two nodes common, then it is called parallel. See, consider the circuit here. This is one node, this is one node. Okay, here. So R1 and R2, are they sharing the same node A and B? Yes or no? The A node is shared by R1 and R2. B node shared by R1 and R2. So when two different nodes are sharing the same different branches in the same fashion, then it is called parallel. See here, two different resistances are sharing common node A and B. Then these two are in parallel. It may be more also. In the same node, it may be 4, 5, 6 may be in parallel. They are sharing same node A, same node B. So this is called parallel. Okay. Same here, voltage also. Voltage is also sharing the same node A and B. So the V, R1 and R2 all are in parallel. It's called parallel, like this, parallel. Series means like this, jama. In parallel and therefore have the same voltage across them. So I told you if they are in parallel, the voltage V is equal to the voltage at R1, the voltage at R2. At R2 I'm telling. So what is voltage at R1? It is nothing but I1 multiplied by R1. What is voltage at R2? I2 multiplied by R2. See, these three will be equal because they are three in parallel. Not only R1 and R2, voltage source also in parallel. So the voltage source V, what it has is equal to I1 R1, which is equal to I2 R2, which is nothing but Ohm's law. So we can write V is nothing but I1 R1 and V is nothing but I2 R2. What is V? Is nothing but I1 R1 or I2 R2, either or, anything. So I1 I can write I1 equal to V divided by R1. I1 equal to V divided by R1. Same I2 is equal to V Taksim R2. Okay, so we got by Ohm's law, we got current relationship with the voltage and resistance. Now we need to have node analysis or node voltages. KCL, Kirchoffs current law. Now we have to apply. What is the Kirchoffs current law? Is telling node A, the current algebraic sum of the currents must be 0. So what is algebraic sum here? Entering, if you take positive, leaving should take negative. What is entering current? I. What is leaving current? I1 and I2. So I can write I minus I1 minus I2 equal to 0. Can I write or not? I can write it. This is called algebraic sum of. Algebraic means here plus minus may come, that means. Okay. So current entering at the node is equal to current leaving at the node also. Okay. How? I is equal to I1 plus I2. Sum of the currents at entering node equal to sum of the currents leaving the node. These two are also valid statements. So it's nothing but I equal to I1 plus I2. Next, substitute these and these in this. So substitute I1 and I2. What is I1? V by R1. Substitute V by R1. What is I2? V by R2. Substitute I2 here, V by R2. Now take out the V common. Take the V common. Then 1 by R1, 1 by R2 will be here. So 1 by R1 plus 1 by R2, I can write these combination, I can write as 1 by R equivalent. I am not writing Zarb R equivalent. I am writing Taksim R equivalent, 1 by R equivalent. Okay. So this is V times 1 by R1 plus 1 by R2. So what is 1 by R equivalent? I can separate out. I can separate out 1 by R equivalent is nothing but 1 by R1 plus 1 by R2. Okay. Now find out this summation rule. What is the summation rule? R1, R2, tahat, R1 plus R2 in the fork. So this is 1 by R equivalent. Now I want only R equivalent. What is R equivalent now? Just opposite, X. So it becomes R1, R2 by R1 plus R2. That is your R equivalent. Zarb, Taksim, Jama. Yeah, if two resistances are there, Zarb, Taksim, Jama. Just, yeah. Multiply the all resistances, means R1, R2, two are there. divided by its total resistance Jama. Means join these two. Simple rule, okay? In series, just Jama. R1 plus R2 plus R3 plus R5 up to. In parallel, R equivalent is nothing but Zerb in the fork, that is R1 into R2, Taksim, Jama. This is valid only for two resistances. Don't think about like a series, Kullu, Jama, 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 Jama. No. Here only for two resistance available, Zerb fork, Sahat, Jama. Okay, let's take Talata Moju, Talata resistance in parallel. So what happens, Talata resistance in parallel? So first two you calculate, R1, R2, R3 Moju, right? R1 first start always with higher to lower B. R2, R3 first calculate. What is R2, R3 equivalent? R2, R3 Zar Taksim R1, R2 plus R3. You got Wahid resistance Rx was Zad resistance module Rx. Now Rx module R1 module. Same rule. R1 Rx Taksim R1 plus Rx. Simple. Because if you know the one rule, you just take that rule is a universal. Think about that only. If ज़्यादा मौजूद इतने calculate. Okay. So like this you have to go. Now this is about the equivalent. Now we go for the current division because already we know V equal to I1 R1, V equal to I2 R2. Voltage are same, but we don't know what is the current. So we have to last step we have to see what is the current. The equivalent resistance of two parallel resistors is equal to the product of their resistance divided by their sum. What I told you. Okay. The equivalent resistance for n resistors in parallel is. Now let us take. I don't want this rule. I don't want to remember the no. I want to different way. I want to remember. Then how to remember? Just 1 by R equivalent. You just find that is 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 1 by Rn. How? What you have to do is first we have to X kullu resistances. R1 मौजूद X keep side. Tani resistance X. Kalata resistance X means 1 by 1 by 1 by 1 by. Then now jama kullu. वाहिद मर्रा jama kullu again X. इतने मर्रा X लाजे. Two times reverse. First time R1 make reverse 1 by R1. Then R2 1 by R2 1 by R3 like this. How many resistances you have? You do it. Then kullu like series kullu jama now. वाहिद मर्रा जमा नतीजा easy. Then X again. मर्रा तानी X हता. Correct answer. Okay. If we have more resistance. If we have only two, this is better. Okay. Okay. Next, we will see the current division. If it is often more convenient to use conductance. Okay. We already finished that, I think. Now coming to the conductance. Now I told you what is 1 by. I told you in parallel what I did. 1 by R1 I did. X 1 by R2 I did. Actually, what is 1 by R1? Resist R. What is R? Resistance means opposing the current. What is the opposite to the resistance? Conductance means free to pass the current. Like your insulator. Insulator means it will stop the current. Conductor, it will allow the current. Okay. So the resistance is the ability to stop the current, means to control the current, we can say. If it is reverse, then it is a conductance, free to pass. So the reverse 1 by R is nothing but your conductance. So the equivalent conductance of n parallel resistance, if we have conductance G, it is denoted by G. So G equivalent is G1 plus G2 plus G3 plus Gn. So what is G1? I told you 1 by R1. What is G2? 1 by R2. Just that's how the resistance is your conductance. See, all are there. Now what is G equivalent? 1 by R equivalent. Now if you want R equivalent, then 1 by G equivalent you can get it. So the equivalent conductance of resistors connected in parallel is sum of their each individual conductance. Like in series resistance, here parallel resistance can be calculated in terms of parallel conductances, which is sum of all the conductances G1 plus G2 up to Gn. For this equation, the equivalent conductance of n series resistance is given by nothing but 1 by G equivalent is equal to 1 by G1 plus 1 by G2 plus 1 by G. What is this equation? For series conductances. Series, if conductances are in series, then your resistance in parallel equation will come like this. Don't confuse here. So follow only one rule what you know. So next, Current division now will come. So the current division is defined as the source current I being divided among the resistors in the inverse proportional to their resistance. Series resistance voltage division. What we have observed there? It is a directly proportional to their resistance into total current. Directly proportional, right? Here inversely proportional. Here inversely proportional to their resistances. Inversely proportional to their resistances. How we can see now? Give the total current I entering the node, the total current what is entering the node, and obtain the current. We know the equivalent resistance of the some voltage R. What is the equivalent resistance? I V is equal to R equivalent. I know that is I equal to what is I is nothing but current is entering total current. What is R equivalent? If two resistance are there, R1 R2 divided by R1 plus R2. Zarb Taksim Jama. Right? So this is your total voltage. Total voltage. Okay. Now current how it is divided? I1 I2 we have to find. Now what is I1 and I2? I1 is nothing but what is I1 in the previous equation? What is the I1? Is nothing but your V times I1. What is I1? Just write the equation. Check the previous slides so they will get be easy. I have to put the equation there, then it will be easy. Just wait. Yeah. What is I1? Yeah. I1 is nothing but V divided by R1. So now what is V? We already got the V equation. What is V in terms of total I? Then we will get I1 plus I2. Then we will get. So I1 is nothing but Taksim R1. So I1 will get now. Here's something I have to add, inshallah. In future I will add. So what is I1? What is I1? V times what is V? Sorry, Ohms law. What is I1? Ohms law as per the Ohms law. I is equal to V by R. V by R, right? So I1, which R is there? R1 is there. I1 means V divided by R1. Taksim R1. So what is V? Already we have. Taksim V. That is I R1 R2 by R1 plus R2. So what is I R by R1? That is 1 divided by R1. So R1 will cancel here. So R2 only remain. So R2 I R1 plus R2. Same equation, but 1 by R1 will be there. It will cancel R1 R1. So R2 will be there. So when we want to find I1, we need R2. Means it is depending on the other resistance, not its own resistance. Voltage drop, it depends on its own resistance. If its own resistance is more, voltage is more. If its own resistance is less, voltage is less. But here in I1 is depending on where? Thani resistance. If Thani resistance is more, this current is more. If Thani resistance is less, this current is less. So it is depending on not its own resistance, other resistance. That you have to see. So I1 is R2I by R1 plus R2. Same. I2 is R1I by R1 plus R2. What is actually I by R1 plus R2? Is nothing but part of the voltage, we can say. So this is how we calculate inversely proportional. Because inversely proportional, it is depending on other resistance. Thus, in general, if the current divider has n conductors, G1, G2 are there in parallel with the source current I, nth conductance Gn will be. What is the conductance Gn will be? Directly we can write In is equal to Gn divided by G1 plus G2 plus Gn into I. So if it is just quite opposite to this one. Quite opposite to this one. Okay, now we have some problems, I think. Yeah, examples, 2 or 3 examples are there, then we can stop. Yeah, just 2 examples. Find R equivalent for the circuit shown. What is R equivalent? Yep. So always. So when it is asked, when the circuit is given and is asked for the equivalent resistance, total resistance, then see where it is asking, from which portion it is asking, which points it is asking. The points are this point and this point. It is asking what is the equivalent. So always go opposite side of that and start. Don't start from here. Don't start from here and go for that side. No. We want here means you have to start from that side and come back. You have to go opposite side of that one and slowly come back. Then it will be equivalent. If you start from here and go end, that's not equivalent. That is exactly different way, wrong way, that is, we can say. So now this is the question. That is, in these 2 points, I want the result, means equivalent. Then I have to start from other side. So which this is the other side. So now we can see 5 and 1 is series. How can we use series? Because this node to this node only 2 resistors are connected. First condition satisfied. And for 1 ohm Thani node and the 5 ohm Thani node, the second node is not common. They're different. So these two are in series. So now these two are in series. What is the resistance? 5 plus 1? 6. So keep it here 6 ohms. But here also another 2 are there, because I cannot do completely here, because these two are again some combination is there. So this node for 6 ohms and 3 ohms is common, and the other node here also 6 ohms and 3 ohms is common. So if two nodes are common for two different branches, then it is a parallel. So now what is the parallel equation? 6 and 3 parallel equation, R1 and R2. What I told you? Zar, Taksim, Jama. Right? Now Zar bata 6 into 3. How much? 18. Tamantash. Taksim, Jama. What is Jama? 6 plus 3. How much? 9. 9. So 18, 4 khada. Taksim, that is 9. So how much? Itne nara. Tamantash, Taksim, 9. Tissa, itne. So now here इतनेन हदा इजी हदा इतनेन हदा equivalent. Now hada itnain and wahid itnain मौजूद ही ना जमा hada, because these are in series. So itnain plus itnain come arba. So hada arba, then hina sitta. Arba sitta now parallel. So sitta arba now parallel. So what is the parallel? Zab and Taksim jama. So sitta arba come 24. 4 Taksim and sitta and arba ashra. Right? 24 Taksim ashra hada jama. So 2.4 now. So 2.4. Now see, hada is equal to hina 2.4. Now arba hada 2.4 and tamaniya kef hada series or parallel? Series hada kullu hada same path. Okay. Conditions you check here. Arba ohm and 2.5 ohm common node is there. The same node is not sharing with the other side. So it is series. Again 2.5 and 8 ohms common node is there, but other node is not sharing with them. So these are in series. So 2.4 plus 4, how much? 6.4. 6.4 plus 8, how much? 14. 6, 8, how much? 14.4 is your result. Check the answer now. 2 ohms, 6 and 3. This is 6 and 3, 2 ohms. Next 5 and 1, 6 ohms. This 5 and 1, 6 ohms. Next 2 and 2, this 2 and 2 is again 4 ohms. Now we got 2 and 2 and 6. So this 2 and 2, 4. So now 4 and 6. These 4 and 6 are parallel. It becomes 2.4. Now we got 2.4 in series 4 and in series 8. So total will become 14.4. Now here one good point is here. See, I know you have good mathematics. You have good calculators. You can do anything in that. You can write big equation. You can get the answers like this. But this is not the solution. Easy way, and to get full marks in the exam. 2 methods you follow. First, topology. Topology means draw the diagram. Next, write all the individual steps. Write more steps, clear steps, you will get full marks. No one will cut your marks. Maybe the answer correct, but steps are missing. They will cut the marks. You will get the question, Doctor, I wrote it. You get the less marks. No. Something is missing there. The Doctor think that, oh, you copied from Tani. Tani never you copy. Because you don't know how to write the steps. Because we need to understand, you know the knowledge, you know the solution, how to get the result. Right? So, 2 things you have to follow. Topology, electrical circuits I'm telling. First, draw the circuit, make small, again draw. Make it small, again draw. Get the result, again draw. Till you get the final result. Parallelly, draw for each one, you write the steps. For these two series, this is the result. For these two parallel, this is the result. Right in the statement. On the right or left, right, draw the circuit also. No one can say that you did mistake. And this will cross-check your answer also. You can easily understand where my answer is gone. Something I'm struck. You can just go back, go back, go back. You'll get the correct solution. So don't think that calculator will give everything. No, I don't need the calculator answer. I need your step-by-step solution. Okay, this is the one example. Another example is there. Okay, calculate the equal resistance RAB, another circuit. Oh, very deep. Complex circuit, right? Now, how can we find? Now, this side we need RAB. So we have to start from right side. In between also, if anything is there, we can do it. So first, these two are in series, right? 5 and 1, 6. Next, this is 4 ohms in parallel. Now, see here. Now, rearrange this one in the down B. This 12 ohms, right? This I can write in between parallel to 4 ohms. This 12 ohms, I can join it here. And this 6 ohms, I can join it here. So this 6 ohms and 3 ohms are in parallel. Good? Can you understand? 6 ohms, 3 ohms are in parallel because there is no resistance here. So I can move this point to here. Then what happens? 3 and 6 will be parallel. So what is 3 and 6 parallel equivalent? Itne. Talata zarb sitta taqsim zayama. Itne ohms. Now again parallel here. 12 and 4. I just move this one to here. 12 and these 12 and 4 are in parallel. So we make it series parallel equivalent. Zarb 12 into 4 taqsim 12 plus 4 sittash. So 48 divided by sittash. Come. Okay, 12 into 4 sittash. 3 ohms. 3 ohms is the natija. So these 4 ohms and 12 ohms are the talata ohms. These 3 ohms and 6 ohms are the itnain ohms. Okay, stop here. Next, here. Come to here. This is 6 ohms in series. That's why 6. And what is the resistance here? 4 and 12. What we got here? 4 and 12. What we got? Talata ohm. So this talata ohm of these two and 6 ohms. What is the natija parallel? 6 and talata? Itnain. So itnain मौजूद ही ना. So itnain plus jama वाहिद कम. ना itnain plus वाहिद talata. Okay, 3 ohms. Now here 3 and 6. How much parallel? Itnain. So ethane and this talata are now parallel. Ethane and talata now parallel. So ethane and talata parallel how much? 2 into 3 divided by 5. 6 divided by 5. 1.10. 1.333 something. Okay. Wahid fasla talata arba. Okay. Now wahid fasla talata arba jama ashra. So talatash fasla 13.344 will come. Check it here. 3 and 6. See, these 3 and 6 in parallel we got 2. Next, 12 and 4 is parallel, you got 3. So, this 5 and 1, 6. So, 6 and 3, you will get some equivalent resistance. Then, 6 and 3 will become 6 and 3, you will get 2 and 2 plus 1, 3. This is 3. Now, 3 and 2 will become 1.2. Then, you will get 11.2, you will get it. So, like this, you have to get the answer. Last, I think, how much time left out? Yeah, so about 5 minutes are there. We can complete it. Okay, find G equivalent in the for the circuit. Same conductance, not a big deal. So these are in Siemens. So when these are in parallel, 8 and 12 are in parallel. So in parallel, what is the rule? Just jama, like opposite to the resistance. So 8 plus 12, 20. So 20 and 5 in series. What is the rule? Same like a resistance in parallel. So 20 and 5 means the zarb and jama. So 20 and 5, 100 divided by 25, 4 ohms. So here it will become 4 Siemens, 4 Siemens. Now 4 and 6 are in parallel. What is the rule? Just jama. 6 and 4, it's 10. So G equivalent is 10. So total is 10 Siemens. Total resistance is total conductance is 10. If you want in resistance time, also you can just reverse this. Each item you reverse it and you can find the same thing. So like this you have to find. Oh, another example. Yeah, same thing. Is there here G equivalent, R equivalent? We got it. Same thing. Now I think another example is there. Next class we'll study this example. Just remind me. Yeah, we'll do it next class.
Today we'll study about delta to Y transformation or Y to delta transformation in our electrical circuit chapter 2. So in this you can observe this diagram. In this diagram, if you see the nodes and the resistance, this is slightly complex circuits than the series parallel combination. How it is complex? So if you see this node on the right side, R3, R6 are connected and R4 are also connected to this node, and these three are generally parallel, but that we cannot solve direct parallel equation here, and we cannot use that two resistors in parallel, then again the two resistors in parallel. We cannot solve that one. Why? Because for any circuit, if two resistors are in series is known by if they are connected to the common node. If they are connected, only two resistors are connected in that node, then they are in series. Like R4 is not there, for example, then R3 and R6 are in series because they are connected to this node. Now R4, now what is a parallel? Now parallel is nothing but when they are connected to two or more resistances in the particular node, and it must share the other side node also. The same resistances must share the resistance, must share the node. Other side node, these resistance must share same thing. Same like the first node, the second node also the same resistance should share it. So then it is called a parallel. Now here this node R3, R4, R6 are connected. Now this node, then R6 is connected, but R4 and R3 are not connected. So these three R6, R4, R3 are not parallel. It's parallel, but it's not, we cannot solve direct parallel equation or rule method. So that's why we came into picture to study about Y and delta transformation. So what is delta transformation? Many, okay, there are Y or T type. So generally one type of network called Y or T type, or another is called delta or pi type. How? First you study what is Y and T type. Just see the diagram. This is how it look like. It is Y shape. R1, R2, R3, they are connected in the shape of Y. Okay, they are connected to the node 1, 3 and 2 and 4. 2 and 4 are together one node only. Just they are stretching, and I shown as a 2 and 4. So which is useful for another type of transformation or another type of network. So here between node 1, 2, 3 and 4, the resistance R1, R2, R3 are connected in this fashion, and this is called your Y network or T network. How it will be tree means just stretch this 1 and 2 when become straight, R1, R2 straight, and R3 on the vertical side, and it become like this. 2 and 4, R3 is becoming like this. Stretch this one, R1 and R2 on the horizontal side, then it become a T network. So the same network can be named as Y or T network. Both are same here. Now coming to the another type of network, that is delta or pi. Now you see here between same 1, 2, 3 and 4 nodes, 1, 2, 3 and 4 nodes, we have a resistance in on the horizontal side RC, and vertical side with an node 1 it is RB, and vertical side with a node 3 RA. So if this is a fashion of topology of a network, then it is how it look like. It is a delta. Okay, it is a delta form. Now why we call pi also. Now just stretch this RB this node to two side, stretch this RA node to the 4 number node side, then it become pi. See, just you have to move this RA this left side, and B on the right and left side like this. Then how it look like? It is a pi network. So that's why Y and T network are same, and delta and pi networks are same. So these are the two types of networks. Now we have to study how to transform these two networks. How to transform these two networks. These networks occurs by themselves or as part of the large network. So these are used in three-phase networks, electrical filters or matching networks. So we have three different applications. These are used in three-phase networks, electrical filters or matching networks. So we'll study those in future subjects or in future chapters. What are the three-phase networks, what are the electrical filters and matching networks. Okay, our main interest here is in how to identify them when they occur as part of the network, and how to apply Y-delta transformation in the analysis of the network. So we'll study now. Now first one, that is Y-to-delta transformation, or delta or pi transformation to the Y to T conversion, that is Y to or T conversion, the result we want from delta or pi. I will start naming one name only, not two, you may confuse. So I want to transform or convert delta network to Y network. I want to convert delta network to Y network. Here in delta also 3 resistances are there, in Y also 3 resistances are there. Just we are converting it from in this fashion to other fashion. Now what is the definition we can say? Each resistor in Y network is, each resistance in the result Y network is product of the resistors in the two adjacent branches, product of the resistance in the two adjacent branches divided by the sum of the 3 delta resistors. So each resistor in Y network is product of the resistors in two adjacent branches divided by the sum of the 3 resistors. What it is? Let's see. So to transform a network from Y, we create an extra node as shown in figure. Just check here. Now the transform Y network, we create an extra node as shown in figure. The conversion rule will be, see what is given question, that is delta, that is A, B, C nodes, RA, RB and RC are the given, means these are the in the question. Now we want to convert these RA, RB, RC to R1, R2, R3. So to form that R1, R2, R3, we have a extra node here, so that we can have assumption or calculations easy to understand from where to where it is connected, from where to where we have to calculate. So we have to convert this RA, RB, RC delta network which is in question, and we have to convert it to R1, R2, R3 star, also called as Y network. So now let us take definition. Each resistor in Y network is product of the resistors in the two adjacent branches divided by the sum of the 3 resistors. So each network, each Y network, let's take R1, we want R1. So what is its definition is telling? It is the product of adjacent means beside, product of beside one. So RC and RB, these are the adjacent. So multiply this RB and RC divided by sum of the RA plus RB plus RC. These are the products, okay, and these are the total equivalent resistance of our R1. Check here, R1 is nothing but multiplication of RB and RC divided by RA plus RB plus RC. Same if you want R2. So what is the as per definition? It must be product of adjacent are connected, same node connected delta resistances, same node connected delta resistances or adjacent resistance, both are same. So RB and RA and RC is the multiplication divided by sum of the all resistances. So R2 is nothing but RA RC divided by RA plus RB plus RC. Same R3, if you want R3, it is nothing but adjacent, RA and RB are the adjacent to R3. So multiply these two divided by all the resistances. Simple equation it is. Just how to remember, you have to know. That's it. Means from delta to Y, it is adjacent resistance multiplication divided by the summation of all the delta resistances. This is the called delta to Y network. Now just we will go for the Y to delta network. Let's take. So Y to delta conversion. So in here definition telling that each resistor in the delta network, maybe left side, right side or down side, is the sum of all possible products of Y, sum of all possible products of Y resistors taken two at a time, means products are there, but at a time two resistance must be the product, not all the three resistance product. Two resistance at a time must be a product and their sum divided by the opposite Y resistor, divided by the opposite side of the Y resistor. Now let us take this is star is given, R1, R2, R3 are given. Now we want RA, RB, RC, the this delta we want. So what I am telling, if let us take we want RA. Now if you want RA, then we have to just multiply R1 R2 plus R2 R3 plus R3 R1, then divided by Taqsim opposite side of this resistance. So RA we want, opposite side is this one, not R2 or R3, opposite side of this is R1, so divided by R1. So see here, so RA is nothing but R1 R2 plus R2 R3 plus R3 R1 divided by opposite sides of the resistance. In the previous case, the denominator in the Taqsim denominator R1 plus R2 plus R3 is the common for all the conversion, but in the in this Y2 delta numerator on the top side is common for all the resistance, only denominator will change. There only numerator is changed, now here denominator will change. RB, what is RB? It is nothing but multiplication of two at a time resistance, that is R1 R2 plus R2 R3 plus R3 R1 divided by opposite side of this resistance. RB we want opposite side, R2 opposite side of the resistance. Same RC opposite side is R3, so opposite side is down, everything is same on the top. So like this you have to calculate. Y and delta networks are said to be balanced when they are balanced, when R1 R2 R3 are same and it is given by Ry, when an RA RB RC are given and is given by R delta. So RA RB RC resistance belongs to delta network, R1 R2 R3 resistances belong to Y network. So these are equal, then they are called balanced. Then I can denote this all three resistances of Y network as Ry and delta network as R delta, RA RB RC as. Now if you go, substitute these values in this, what happens, see. Now substitute this RA RB RC. Now substitute R1 R2 R3 as Ry. So now substitute R1 R2 and R3 as Ry. So this become Ry everywhere it become Ry. So Ry square, Ry power 2, Ry power 2 divided by R1, that is Ry. So it become 3 times Ry divided by Ry. So Ry cancel, it become 3 Ry, means R A, what is RA is nothing but R delta. So R delta is nothing but 3 times R star or R Y network. So like this, if you substitute in the previous one also, it is R delta by 3 will come. So now what we substituted here, it become R delta. R delta is nothing but 3 times Ry. Now take the 3 this side, then it become Ry is equal to R delta by 3. Or you can substitute the values of these in the previous what we called delta to Y transformation. Its same result will come. So like this we have to find. Generally for assuming, we can say Y connections are like a series connection and delta connections are a parallel connection. Okay, so now come to the problem. Convert delta network to the equivalent Y network. So this is your delta network. Now I want a Y network. So Y network is how we will form from A, B, C. We form a extra node N here, and one is resistance here, one resistance here, and one resistance here. Okay, for RA and RB, R1 let us take, R2 like this, anything you can take, but we have to connect a 3 resistances in between. Okay, so like this we have to connect with the extra node. You can assume this is as R1 and you can take this as R2 and this is as a R3. Now what is the definition for the delta to star? Delta to star, I told you, adjacent side multiplication divided by sum of the all resistances. Adjacent side of these R1, this R1 adjacent side is 10 and 25, so 250. 250 divided by sum is nothing but 25 plus 10 plus 15, 50. So 250 by 50, 5 ohms. So like this we have to find like this, 10 into 25 adjacent, 10 into 25 divided by 15 plus 10 plus 25, 250 by 50, 5 ohms it's coming. Now same thing, R2 adjacent, 25 and 15 are the adjacent for this R2, divided by sum of the all. See, 25 and 15 are the adjacent for the R2 and divided by sum of the all, RA plus RB plus RC. Now it becomes 7.5. Same thing, R3, it is adjacent is 10 and 15, it must be multiply. 10 and 15 multiply divided by sum of the all resistances, it is 3 ohms. So like this we have to calculate all the transformation from delta to star. If it is delta is given, we can go for the star, and if star is in the question, you can go for the delta. So all equations are with you. Now we will go for the summary. Now in the chapter 2, what are the items we studied? We have some summary, small summary. So we studied of the Ohm's law, that is V is equal to IR. Now Ohm's law in terms of power, voltage, current and resistance, you can have a pie chart like this. So all are the equations are given here with I, V and P and R. Now another method also we have, that is called matrix table, Ohm's law matrix table. Same voltage, current, power and R, if when they are included, these are the table. When current resistance is known, we must know what is V, that is IR. What we must know, power in terms of current and resistance, I square R. Like this all equations are there. If you want, you can just take a printout and you can put on the somewhere in the wall on your room, so that every time when you come and enter, you can see it and you can remember it. So this is the pie chart and the matrix table. Now coming to the some statements. See, Kirchoffs current law and Kirchoffs voltage law also we studied. What is the Kirchoffs current law? Currents entering in the node equal to currents leaving the node. See, I1 plus I2 plus I3 are the entering, and I4 and I5 are the leaving. So this is equal to 0. Now what is Kirchoffs voltage law? Kirchoffs voltage law is nothing but the sum of all voltage drops around the loop is equal to 0. Now let us take, this is the one loop and we have 1, 2, 3, 4 branches. A, B, C, D are the nodes. Then with first node, if we are starting with A, so the voltage will be VAB for this branch, then VBC second, VCD third, VDA fourth. So all the voltages must be 0. VAB plus VBC plus VCD plus VDA equal to 0. So now have some summary again. A short circuit, what is a short circuit? It is a perfectly conducting wire with resistance 0. Whenever you ask what is a short circuit, means R must be 0, all electrons are freely allowed to pass, no stoppage. And what is an open circuit? Then it is called infinite resistance, R is equal to infinite, means no electrons are passed, they are stopped. So this is a open and short circuit. Now what is the conductance? Conductance is the reciprocal of the resistance, G is equal to 1 by R. Or we can say X, inversely proportional or reverse of the resistance. Now a branch, what is a branch definition? Is a single two terminal element in electric circuit, we know it. Now node is a point of connection between two or more branches. If two are connected, it is series. If more connected, they are in parallel. A loop is a closed path in a circuit. With this also we studied. Now what is the topology of between these three? Branch, node and loop is nothing but branch is equal to loops plus node minus 1. When elements are in series, the sum current flows through them, I1 is equal to I2. The same current flows through them, sorry. So when elements are in series, the same current flows through them. If the first element we are calling as I1 and second element we are calling as I2 current is flowing, then I1 must be equal to I2. Parallel voltage is equal. When elements are in parallel, the same voltage flow across them. That is, first element V1, the second element is V2, then V1 is equal to V2. Here element and branch both are same here. So when two resistance are R1, that is reciprocal of G1, and R2 reciprocal of G2 are in series, then it is R equivalent. When two resistance are in series, what is that? R1 plus R2, and G equivalent will be G1 G2 by G1 plus G2. Same opposite to the parallel. Then parallel R equivalent will be R1 R2 divided by R1 plus R2, and G equivalent will be G1 plus G2. So this is how we studied the all the items. Now come to the voltage division and current division. The voltage division principles for two resistors in series is nothing but it's the same resistance multiplied by voltage divided by the total resistance, and the other voltage is its same resistance multiplied by voltage divided by the total resistance. and current is the in parallel is nothing but it's other resistance multiplied by the total current divided by the total resistance. It's I2, it's other resistance multiplied by the total current divided by the total current resistance. It is the current division. It is quite opposite. These two are quite opposite, series and parallel. The formula for delta to Y transformation are R1 is nothing but adjacent side resistance multiplication divided by the total resistance. Adjacent resistance multiplied by divided by total resistance. R3 also adjacent resistance multiplication divided by total resistance. But in the Y to delta transformation, it is the multiplication of two at a time combination multiplication plus all the resistances divided by the particular opposite side of the resistance, opposite side of the resistance. So like this we have R1 R2 plus R2 R3 plus R3 R1 common for all the three, and divided by is the opposite resistance. So like this we have star delta transformation or Y delta transformation or delta to Y or Y to delta transformation. Now we have some problems which is given. All are based upon your Kirchoffs law and KVL, Kirchoffs voltage law and Kirchoffs current law and Ohms law, and on these equations only these all problems are related. And one thing we have to see that step by step you have to complete the circuit. Now another set of problems are to reduce the big circuit to the equivalent circuit. Means we have many resistance are in series and parallel, so make it the single resistance, make it to the one resistance network. That is, more resistance are there, just solve series to parallel, parallel to series, then make it to one resistance. So those problems also included here. This is uploaded in the blackboard, you can just go through. Here in the last slide we have the star to Y to delta and delta to Y transformation questions also there. Okay, for the next class we have the quiz. On the quiz, chapter 1, chapter 2 till last class what we study. In quiz, delta to Y and Y to delta is not there, so no need to study about this for the quiz. For the mid exam, final exam, you have to study that one. Okay, so this is how we have to complete the chapter 2.